Hi there, in this engineering illustrated video, we will explore the physics behind the exploding of capacitors. Now, a little background about capacitors. Their primary function is to store energy, and this energy is done through electric fields. Now, let's look at what happens if that energy is released too quickly. Now, let's have a look inside a typical capacitor. So basically, a capacitor has two plates, a positive and a negative conductive plates, and these plates are separated by a material called a dielectric insulator. And what this dielectric insulator does, it basically isolates the positive and negative plates from touching each other or causing a short circuit. At the same time, this is where the energy is stored that is generated by the electric field in the capacitor. So these plates, they basically create an electric field, and that electric field travels from the positive and the negative plate to the negative plate, and in between those plates, this is where the energy is generated, controlled, and stored by the dielectric insulator. Energy that is stored in the dielectric can be expressed mathematically in this formula, where we have E is the total energy that is stored in the capacitor equals the half times the capacitance of that capacitor, and this is constant, times the square of the voltage. So let's assume we have a capacitor and it's rated at a specific voltage, let's say 5 volts. Now, it's designed not to handle more than 5 volts. So if we increase that voltage, what's gonna happen is the energy is gonna also increase proportionally to the voltage. And when a high voltage occurs, the energy that is stored inside the dielectric can basically break down that dielectric because the capacitor is not designed to handle the voltage that is exceeded to the rated voltage that it was designed for. So if we look inside, basically, inside any capacitor, let's say this is a very simple drawing of a capacitor. We have the two conductive plates, and we have the dielectric material, and it's normally charging. And in case any of these scenarios occur, let's say an overvoltage, so it receives a voltage that is higher than the voltage that it was designed for, or it basically got heated, or the polarities are reversed. So if we power up or if we feed the capacitor and flip the polarities from the battery to the capacitor, basically we'll get a short. Or normal wear will also, all of these will cause what's called is a breakdown of the dielectric insulator. So dielectric insulator, if this breaks down, this is the only thing preventing the energy that is stored here to be released. So when that happens, there is going to be a sudden release of energy that is so strong, it's going to cause to basically break down the physical material of the capacitor, and heat will build up, and then there will be it's basically like a short. What's happening is like a short circuit, and then it will rupture and explode. And why does this happen? Because typically, like a short circuit, there will be arcing inside, and the energy that is stored will find the weakest spot to release from the capacitor, and basically you'll have smoke coming out initially, and then it will explode. It will explode, and in some cases, it will even light on fire. So we saw what happens on the inside, and typically on the outside, what would happen is initially there will be bulging happening slowly on the capacitor. Then a little steam might come out, and then it will instantly rupture. as shown here. And as I said, in some cases, it will even light up, and there will be a fire. So this depends on how much. Again, it goes back to how much energy is stored. The higher the energy, the the stronger that release of energy will happen, and this is basically the way the energy is released. That's how we can see it. So the higher the energy, the higher the sparks, the explosions, and the damage that will occur. Thank you for watching this engineering illustrated video. If you want to see more videos on electrical engineering, power systems, electronics, please like, share, and subscribe.